Now we'll see how Genexus determines the base table to navigate to satisfy a query. And we'll focus on the for each command. When this command has a defined base transaction, then the problem is already solved. The question is, what happens when it doesn't? How should the base table be found? Genexus searches for the attributes existing in all these places, and based on them, it searches for an extended table that contains them all. For example, if the attributes that appear in these places are from these tables, which will be the base table of the for each? It'll be this one, because its extended table contains them all. It could be possible to argue that, if the choice was this other one as base table, its extended table would also contain all the attributes. So, it becomes necessary to add a condition. It should be the minimum table of all the extended tables that contain all the attributes. That solves the problem, and the table will be this one. Obviously, in the case that an attribute of this table appeared, then the base table would be a different one. Consider it in this example. There is no base transaction. This attribute is here, this other one here, and this other one is here, and this other one appears in the main code. The navigation list will show we see that it's choosing trip attraction as base table. But what happens if there's no extended table containing them all? For example, if you add hotel name in the print block, Genexus will show an error and it will not be possible to generate the object. Note that if, for example, trip attraction had been specified as base table, then instead of an error, there will be a warning about the hotel name attribute being unreachable. But the base table will be perfectly determined by the base transaction. All this, related to a for each, also applies to a grid with base table, as well as to a group of data providers. And the same goes for a data selector executed as an independent query or a formula. Now, what happens in the case of a nested for each? The base table of the main for each is determined without taking the nested for each into account at all. That is to say, as if it didn't exist in the main code. How is the base table of the nested for each determined? It's always defined after determining the one of the for each that contains it. The case that should be analyzed is when there is no base transaction. It could be considered in a similar manner, taking the attributes found here, suppose these ones, and finding the minimum extended table that contains them, regardless of the main for each. However, it will not be exactly that way. In fact, from all the attributes extracted from the places already known, the first thing to do is remove all those that are also part of the extended table of the main for each, to operate only with the ones remaining, in order to find the minimum extended table that contains them. In this case, when you remove, from the set of attributes to be calculated, those that belong to the main's extended table, then you'll have none left, an empty set. In such a case, the base table of the nested for each will be the same as the one of the main for each, and it will then be a control break. Here's a particular example. Whether trip attraction is specified as base transaction for the main for each or not, due to the attributes involved, the base table will be trip attraction in any case. And for the nested for each, since the attributes used in it are from this table, and from this other table, its base table would be this other one. But it so happens that it's located in the main's extended table. So, Genexus will select the same one, trip attraction, as its base table, and the control break will take place by category name. If, for instance, you added an order by hotel name, then things would be different, and the base table of the nested for each will be hotel. Note that here, from these three attributes of the for each, you'll have to remove this one and this one for the calculation of the base table because they're already in the extended table of trip attraction. Only hotel name remains for calculating the minimum extended table that contains it. This is so because, in the nested for each, you could possibly use attributes from the main's extended table to do something with the perfectly determined values of those attributes. For example, imagine that, in the print block of the nested for each, you add hotel name, which makes no difference, and also attraction name. In determining the base table of the nested for each, neither country name nor city name or attraction name will participate because they're in the main's extended table. It's clear that the base table will be hotel. What will be executed? For each trip attraction going through the filters, there will be one value of attraction name, and that value will be the one shown for each record of the nested for each. Likewise, for all hotels in the city of the trip attraction, that country and city will come up, along with the name of the hotel and the name of that attraction. It will always be the same one for all these records. It's important to bear in mind that the attributes in these places will not take part in determining the base table of the respective query. Of course, it's possible to specify base transaction for one and not for the other. After, and only after, the base tables have been determined, GeneXus will solve the navigation, and, more specifically, the conditions that it will implicitly impose. For example, remember that if no access to a particular table of the extended table is required in the for each, for example, suppose that only attributes of these tables are used, then the access will be to these tables of the extended table and not to all tables. These two will not be accessed. Therefore, if in the parm rule you receive in an attribute of one of them, that automatic filter, based on equality, will not be applied to the for each. And that's because the implied conditions are placed after the navigation has been defined. The other clear example, the specific navigation is defined only after the base tables have been determined. This means that, first, you must know the base tables in order to determine the case. For example, finding if there's a direct or indirect one-to-n relation or not. And what about determining the base table of a nested for each at n level of nesting? It's logical that it may use attributes of the extended tables from its ancestors, and not only from the parent. In addition to parent-child inferences, there are also grandparent-child inferences. In fact, inferences take place with any ancestor, and control breaks are only at the parent level. What might happen is that the parent level could also be control break with its own parent. And that will be the end of this topic.